Hi guys, in this video we are going to talk about resource management technique chapter number 2, linear programming problem in mathematical formulation. First, let us see about introduction of linear programming problem. Linear programming is a mathematical technique for choosing the best alternative from a set of feasible alternatives which the objective function as well as the constraint can be expressed a linear mathematical function. That means linear programming is the analysis of problem in which the linear function, that means function of degree 1, of a number of variable is to be optimized, either maximized or minimized, when those variable are subject to the number of constraints in mathematical linear inequalities. Next, let us see about define LPP model. The linear function to optimize maximum or minimum is called the objective function, which means LPP is a technique of finding the optimal value of a linear function of a several variable subject to the same restriction. The general LPP called for optimized maximum or minimum, a linear function of the variable is called the objective function. Second step, the condition expressing the relations between the variables are called constraint, which means subject to the set of linear equation or inequalities called the constraint or restriction. Third step, the variables that appear in your objective function are called the decision variable, which means the variable, that is the decision variable x1, x2 up to xn involved in the objective function are called the decision variable. Next, we are going to see about canonical form of a LPP model. The objective function is to be maximum or minimum z equal to c1 x1 plus c2 x2 plus up to cn xn, which means the linear programming involving more than two variables. The linear function z equal to c1 x1 plus c2 x2 plus up to cn xn, which is to be maximized or minimized, is called the objective function. Second step, subject to the constraint. This is the relations between the two function a11x1 plus a12x2 plus up to a1n xn less than or equals or greater than or equals b1. Similarly, a21x1 plus a22x2 plus up to a2n xn less than or equals or greater than or equals b2, etc. up to mth term am1x1 plus am2x2 plus up to amn xn less than or equals or greater than or equals bm. That is, there are always the certain limitations of the uses of limited resources. These limitations are called the constraint. Third step, all the non-negative restriction x1, x2, x3 greater than or equal to 0, the variable x1, x2 up to xn involved in the objective functions are called the decision variable. Next, let us see about characteristics of LPP model. The objective function is of maximization or minimization type. Second step, all constraints are less than or equal or greater than or equal type. This is a construction, the maximized or minimized type. All the variables x1, x2, x3 are non-negative. These are the decision variable x1, x2 up to xn. The objective function and the constraint will be the degree 1. Next, let us see about procedure for forming a LPP model. The following steps we usually adopted in a mathematical formulation of a problem. These 4 steps we can use the mathematical formulation. Step 1. Define the decision variable, which means identify the unknown decision variable to be determined and assign the symbol to them. Step number 2. Construct the objective function in terms of these variables, which means identify all the restriction or constraint in the problem and express them in a linear equation or inequality of decision variable. Step number 3. Write down the constraint with the help of which the objective function is to be optimized, which means identify the aim or objective and represent it also as a linear function of decision variable. Step number 4. Write down the non-negative constraint or x1, x2 greater than or equal to 0. These are the decision variable. Express the complete formulation of LPP as a general mathematical model. Thank you guys. We will meet in the next chapter.